And if you have questions, I have the chat open. So if you feel more comfortable just putting a question in chat, I always say that I may want to finish my thought or finish my slide before I answer a question, but I will get to it. So great.
Without further
And
ado, so it's 7:12. I'm going to give you a hard cut at the 30-minute mark, if that's okay. So if you
great.
wrap up.
30 minutes sounds good. Yeah, we'll make it happen.
All right, thanks.
So 7:32 sounds good. Great. All right. Let me move through this then. So real quick, I just want to talk about my employer. I'm going to mention them one time and then not any other time, but they're paying for me to do this. So Fusion Auth is something like Firebase or Firestore. No, Firebase. It's a user data store, so it doesn't do all kinds of data. It does just user authentication stuff. It has it's free as in beer, supports a number of different technologies, and the reason why it's material for this presentation is we produce a lot of JWTs or JOTs. About me, who cares? You didn't come here to learn about Dan Moore. You came here to learn about JWTs. This is my question slide. Again, feel free to ask a question with your voice or in chat. And as we already saw earlier, my internet connection is, I think it should be more stable now. I kind of shifted things around, but if I do lag, please just kind of go ahead and put a note in the chat and I can go back to that slide and review it. So JWTs briefly, it's a JSON web token. It's actually pronounced JOT, which was news to me when I kind of started learning about them, but it's a standard from the IETF 7519. And really what they are is stateless, portable identifiers. So you can basically encode a JSON object, you sign it so that you know that it hasn't been changed, and then you turn it into base64, and then you can send it in headers, you can send it in forum posts, you can send it as query strings, although you probably shouldn't. And it's really great for APIs because you can have an identity provider generate this JOT and hand it to a client, and that client can present it to various different APIs who can decode it, examine it, and determine what level of access this holder of this JOT is allowed. It's a base64 encoded string. So let's just kind of walk through this scenario. So we have a typical kind of microservices application here. We have a user API and a to-do API. We have these clients over on the left. And the user API looks like this, nothing crazy, just a normal user database. The to-do API has to-dos in it. And that to-do table might look a little bit like this. You have to have some kind of identifier, you have the text of the to-do, and then you have the user ID, which references which users' to-dos are recorded. If you are building a mobile application, you might have that post to the login endpoint, which would then go against the user API, and that data would be retrieved from the users table, and then we would send back JSON, right? And so then the JSON might look a little bit something like this, right? It has identifier, has my name, what roles I have. And then to get my to-dos, the client would then pass that user ID up to the to-do API. And then the to-do API would go against the to-dos database, pull that back, whatever to-dos I had, and then send back JSON. And then the client could render it. The issue with that, of course, is that you can, a malicious client might look at the network traffic and say, oh, they're just passing user ID. I wonder what user ID one, what their to-dos are. And so you can basically iterate that ID because it's a reasonable identifier. And obviously that's not a great idea. Some things are really, really important. And the fact that I don't want anyone to know that I have a task of going to get milk from the store, for example. That's important to keep secret. So what you can do is kind of take the next level up, right? Which is you have the user API generate this opaque token. That opaque token gets handed to the client. The client then presents that to the to-do API. And then the to-do API gets this token. Well, it can't look that up necessarily. It doesn't really know what that is, but it can pass that token back to the user API and get back the user's JSON. And then go ahead and use the user ID or whatever other identifier for the user is to pull the data out of the to-do database or data store. Makes total sense. Has a couple of problems. So basically, you need to maintain this user token mapping. The user API needs to kind of keep track of those. And it's chatty and it couples the user API to everything, right? Anything that gets this token now needs to talk to the user API. Now, when you only have 2 services, not that big a deal. But if you have 20 or 30, then everything needs to talk to the user API. And you need to make sure that you can scale that it's available all the time. The next iteration is to use a JOT, a JSON Web Token. And so in this case, the user API generates the JOT and passes it to the client. The client, again, it might as well be opaque to the client. They can look at them and decode them. And we'll talk about some of the security ramifications of that later. But they don't have to. They can present that to the To-Do API. And now the To-Do API can actually look at that JOT. Because it's signed, it knows that it came from the user API, so it hasn't been changed over the wire, which obviously is a huge security risk. And it can look at that user ID, it can look at the roles of that user without ever talking to the user API. So that really is the reason for JOTs to exist. That's why they're useful, is they decouple the identity from they decouple who consumes the identity from who generates the identity. The other nice thing that you can do is you can actually sign them with a public-private key pair. And so in that case, you can verify that the user API generated this JOT without sharing any secrets with them. And we'll kind of see how that would work in a couple of slides. The one thing that's worth driving home is that you don't want to put any secrets in your JOT. So you don't want to put any secrets in it. The JOTs are cryptographically signed typically, but they're not encrypted. So that means that anybody with a JOT who happens to, whether that's a malicious client, someone who's man in the middle attacking you, something where a JOT gets put into a browser cache or something like that, anyone who gets that can decode everything in there. So that's why I think it's a really good idea to put only kind of public-ish information in there, and you wouldn't want to put any secrets in a JOT. But you can put an ID, and then later you can pull things out by that ID. So here is a JOT in all its glory, and they have 3 different clauses. There's a header, which is that light green, the payload, which is the blue, and the signature, which is the tan. And we're going to look at each of those in turn. So the JOT header it can specify the algorithm that was used to sign the JOT. It can specify that it's a type of JOT. It can specify a key identifier. There's a couple of other things that can be put in there. And it's, again, this is just URL encoded, JSON. The payload is slightly more interesting. This is, again, a JSON object. You can put whatever the heck you want in there. And there's a couple of different kinds of claims. Some are standardized, some are in the specification. And IS is one of those, and this is basically the issuer of the JOT. So that's some identifier of the user API in the diagram that we've seen in the past. There's an expiration time, which is just the epoch seconds. And then there's an audience, which is who this JOT was created for, who's supposed to consume this JOT. And there's a sub claim, which is basically the subscriber or the person or thing that this JOT is about, that this JOT is describing. And so those are all claims that you should really look at as a consumer to verify that this JOT is who you expect it to be for. Because remember, the consumer is what's looking at this JOT and then verifying whether or not they're allowed, the person or the entity presenting this JOT is allowed access. The signature is basically just a cryptographic signature. It's encoded of the payload and the header. So when the JOT is presented to the To-Do API, it can decode that JOT and it can see the subscriber ID, and then it can do a select star against the database from the to-dos where that user ID is presented. That's the end kind of goal of all this. So a couple of interesting hacks around JOTs. You actually don't have to sign them, and that's a bad idea in general. There are a lot of different options and a lot of different ways to can kind of assemble them. And then again, it can contain a JSON object, but you shouldn't put anything there that you wouldn't want someone who gets the JOT, whether that's again a malicious client or somebody else, to be able to see. So here's a little bit more in depth about dropping the signature. So you can get rid of that red part, which is the signature, and that turns the JOT into this. And again, the header is still there, but it changes the algorithm. Making this particular choice changes the algorithm to none, and the payload stays the same. So whenever you see a JOT that has that's missing that third clause, that's what you're seeing is algorithm none. So the specification allows this, and the short answer for that is that you just don't ever allow it. And you as a consumer should actually, if you see a JOT signed with algorithm none, that means that you don't have any guarantees that someone didn't just create it or some other system didn't just generate this JOT, and then you can't really trust the payload, right? Because the payload could be adjusted very easily. Now, there's always a depends. I'm a former consultant, and so if you have some other way to verify a JOT is unchanged, whether that's RFC 8705, mutual TLS, whether you're all over VPN, whether your clients are all isolated on a private network, then you could use a JOT, especially if you're really concerned about performance and you've benchmarked that. You can use, as I had mentioned earlier, public and private keys. The JOT I showed you earlier was actually signed with a symmetric key, the HMAC algorithm. If you want to use public-private, the nice thing about that is that this user API can sign their JOT with a private key, and the to API can actually pull the public key from the user API, and then can verify that that user API did sign this key. And I've seen it with RSA, I've seen it with elliptic cryptography. So you have a variety of algorithms to choose from. That's really great if you actually are in a big organization or possibly cross-organization. And this user API is managed by one set of people, and they don't really trust or have the ability to share a secret with the people who write the to-do API. Then using public-private key pairs lets you get around that. So this is what it would look like. And if you have multiple keys, you can actually specify in the JOT header, the key ID that it can then, again, this is just at a well-known endpoint, you can have a list of public keys. So the resource server, the to-do API in this scenario actually pull the key that was used to sign the JOT. It'd also be useful if you were rotating keys as well. Real quick, kind of how to choose the signing algorithm. You want to think about how many different systems you're going to use. You want to think about, can you share secrets? Can you trust the secret to other systems? If that to-do API and the user API are both using a symmetric algorithm to verify the signature, then the to-do API has the same secret as the user API, which means that the to-do API can actually generate a signed JOT that would look just the same as if the user API generated that. That may or may not be an issue depending on how your system is structured organizationally. You want to think about rotation of keys. It's easy to rotate public keys, and then performance. Symmetric keys are faster than public-private keys. Refresh tokens are an important part of JOTs. JOTs are supposed to be short-lived, and refresh tokens are longer-lived and basically can be used to mint new JWTs. So in this case, we would have the user API would hand down both a JOT and a refresh token to the client. And then when the client would pass the JOT to do API repeatedly until it received a message from the to API saying, hey, this JOT is no longer valid. in which case it would catch that, and it would pass the refresh token back to the user API, which could then mint a new JOT. Pass that to the client then presents this to the Zoo API. And that's a way for you to keep JOTs short-lived, but still not require your user to authenticate regularly. If you're deleting users, you might use something like this in a normal, kind of monolith, but you don't have on-delete cascade when you're building a distributed system. So you have a couple options here. One is you can push the complexity to the client, which I'm not typically a fan of. It doesn't scale very well. Or you can push the complexity to the server side. And what you can do is you can have any API that's interested in hearing about a user being deleted, right? So that they can delete the to-dos or clean up when someone basically uninstalls an application or deletes their account. Those APIs can register and receive an event that, hey, this user's been deleted. And then the client just has to fire one delete event, and everyone else is responsible for cleaning up after themselves. Log out, you want to basically refresh the revoke the refresh token. You don't really have a great way to revoke JOTs, and we'll talk a little bit more about that later. When logout happens, the client should remove the refresh token, remove the JOT. The user API marks that refresh token as being invalid. So if someone else presents that refresh token, they're not going to get a new JOT. But there's a JOT kind of floating around here that someone else could have intercepted. Again, if you want to log everyone out, make sure you revoke all the refresh tokens. Or if you want to log one person out, you've kind of given them multiple refresh tokens, you want to revoke all of those. So can you revoke JOTs? Well, sort of. If a user account's been breached, that's typically a bad thing. You have a couple of options here. The first is you can wait it out, because all JOTs should have a short expiration time. And depending on the severity of the breach, like who the user is, what your comfort level is, you may just want to wait for 5 or 10 or 20 minutes whenever the JOTs expire. That's probably the least secure option, but it could be a valid option. You can rotate your keys, which depending on how many keys you signed or how many JOTs you signed that key with, could log everyone out, right? Or it could log just a portion of people out. So that's kind of the light on fire kind of option. You also have this time window solution, which basically pushes some state into the various consumers of the JOTs. I'm going to kind of scoot through this pretty quick because I don't have a ton of time. But in this case, you in addition to registering for delete events, you register for log out events essentially. And then the to-do API can keep track of who has logged out. And if that JOT is presented to them for a subscriber who has logged out, it can refuse it. So again, it kind of defeats some of the purpose of JOTs because it makes it more stateful, but it gives you that tighter window of possible unauthorized access. So I'm going to skip through this. I'm going to skip code because I have 2 minutes left. So as far as JOTs and JavaScript, I think you want to think about what are you trying to accomplish. If you're generating and parsing JOTs, then there's a great JSON web token package. And then if you're thinking about authorization, I have not delved deeply into this. I Googled a little bit, and there are some pieces of middleware out there that will look at a JOT and examine it and see if it's valid, and then basically do authentication based on that, or authorization, excuse me. Here's some tools. Here's a debugger that you can actually cut and paste my JOT from my slides into and see what it looks like. There's a code I didn't have time to go over, and then I wrote an article about how to build a secure JOT from the identity provider perspective, from the consumer perspective, from the client perspective. So that would be worth looking at. And then thank you. Thanks for having me. If you want to contact me, or I'm happy to chat over email about authentication systems, Fusion Auth, or JOTs.
Awesome. Thanks so
Thank
much,
you.
Dan. That was awesome. Anyone have any questions? Dan, do you mind just dropping some contact info in the chat for anyone that wants to get in touch with you after?
For sure, I'll do that.
Hi, Dan. It was a nice demo. I have one question. By the way, my name is Sriram. This is the first time I was joining in this meeting. The question is like, I was building one app. So I'm using JWT, and my backend is Node.js and front end is React.js. I was in a bit of confusion, like the way how I implemented JWT is I'm attaching to the cookies rather than putting into the local storage, because I want to suppress the headers. So which one is the best practice, like putting it in local storage or putting it to the cookie and make it as HTTPS? Because sometimes while I'm closing the window, like local storage is in some browsers is not clearing up. So what would be your suggestion on that?
Yeah, that's a great question. So, basically it sounds to me like a meta question is, where do you securely store a JOT on a client, on JavaScript client in a browser? And local storage, I would not use that because that's really open to everybody. I think an HTTP cookie or a cookie is still, unless it's set to HTTP only, it is accessible to any thing that's running in the browser, right? Like that's running on that page. So, it really does depend on how secure you want things to be, but our recommendation actually is never put the JOT in the browser at all, right? Have that node middleware hold the JOT, and then use the session to kind of connect the client to the JOT. Now that doesn't always work, and so our second, the second best solution is a secure HTTP only cookie. That means that you're not going to be able to reach it with JavaScript, which means you won't be able to push it into a header with fetch or something like that. But you just have to think about the security ramifications of somebody else getting your access token. And again, that goes back to that time window solution or those options. Like, what would happen if an arbitrary piece of JavaScript from an attacker got your JOT? Like, would it be a horrible thing? Would it be like, it's okay, it's just dog pictures or whatever? You need to make that kind of security decision, but those are our recommendations. Does that help?
Yeah, that's okay. Yeah, that's good. Thank you.
Yeah, thank you.
Cool. Thanks so much, Dan.
Yeah.
If anyone has any other questions, just reach out. Dan will drop some info in chat. So next, I wanted to actually go a little bit out of order, if that's okay with Brian. So for you, Tom, it is currently 2 a.m. So if it's cool, we can get him up next. And he's actually talking about something that I've used in the past and I think is super cool. So Tom, take it away. Oh, same question. Do you want people to interrupt you, or do you want people to hold off?
You can just ask questions during my talk. There's no problem. First of all, thank you for squeezing me in. It's 2:30. It's almost 2:30 a.m. here, and I have mosquitoes here also because it's too late. I will also leave my email here if you get any after my talk. If anyone has further questions that I won't be answering during my talk, you can just email them to me, and I promise to answer everything. So first of all, nice to meet you all. Thank you for having me. Thank you, Shimon, for having me here. My name is Yotam. I'm from Tel Aviv. I'm a front-end developer and a developer advocate at Codota. It's a small Israeli company. We're based in Israel and in the States. And we have two main products that are both plugins for almost all IDEs. We work with all the main IDEs, with all coding languages. And these are AI plugins. They're GPT-2 based and work with its neural network. And I'm sorry for my English. I'm not a native English speaker. And I will be putting on a demo on tab 9. Maybe some of you heard of it. We already have. This month we just got 1 million monthly active users. And thank you very much. And I want to show you how it can increase your workflow, how it can take like everything you do while coding. It can just double the speed that you work, make it more accurate. And let me just show you how it's done. I'll just share my screen, and it's going to be this screen. Okay. So first, do you need me to take the font, like to put the font bigger, or is this big enough?
Okay.
It's okay. Everyone can see the characters. Okay. If there are no, I'll just continue. So first of all, tab 9 can be downloaded straight to your IDE. I'm using Visual Studio Code. You just type down tab 9, take it from the top of the list. Well, here it's already installed, but you just press install, and it's ready to go. It's an auto-completion tool that was trained on more than 10 million open source pages, mostly GitHub repositories, but also Stack Overflow and similar platforms. And on top of the fact that it was already trained from common knowledge from the world, you might say, it also keeps on reading the project that you're currently working on, and it's making conclusions that help you write the code faster. For example, here we have a JSX file. It's a React component, and see what happens when I just start type. Let's say, first of all, it's a React component, so we need to import React here. And you can already see that I get code suggestions that are not just completing the word that I'm writing right now. It's already completing the whole code line. So we already have import React from React. We want to add the component, and it completes me before I even do anything. I just tap down and I press enter. Now we need to export this component to the app itself, and it's already and it knows how it works. So I'm just writing one word, and I already have most of what I need here. So let's say that we're writing a component that deals with names and dark mode. It can be anything. So let's call it dark mode. Okay. And it extends component, that's correct. And the next thing that we have in our React component would be the state object. So I'm just writing state, and it's already there. Well, here's the thing about AI. You can use it to help you do the repetitive and the tedious work of writing the same thing again and again and again. While it can increase the speed that you're working by completing the code line that you're currently writing, it can also offer you solutions that were already solved by millions of people before you. I guess that most of you people here are JavaScripters, are code writers, and we know that half of the time of our work is searching online for code solutions and for code examples that were already made by other people. And if we can cut down and cut off the hours spent just searching online for things that people already do, and we can just get it straight in our IDE, it makes things so much easier. So in our state object, let's create is dark mode. And you see that it already knows that since I have a variable here that starts with is, then it's probably a Boolean. It offers me true or false. Well, I go for false. And let's say that, well, it's a dark mode name. So we also need a current name here. And let's call this name Shamun. You are my designated person, Shamun. So now we need handlers. Okay, let's take it to a more complex situation. So I need a function that will handle my dark mode. So I have a dark mode handler, and it will get an event as a parameter. And I want this handler to affect the state that I already created here. I want to change it, so I need the whole this set state prev state method, and we can predict that tab 9 will already know that I need one of those. So, for example, I want to change my prev state here. And now I need to change my isDark mode to not what it's been before because I'm changing it. It's a Boolean, it's a toggle situation. So if I choose isDark mode, I'm sorry, I'm missing this here. Let's do this again. IsDark mode, prev state, isDark mode, not prev state, isDark mode. Yes, correct. That's it. I wrote about 5 characters and I get the whole function running. This can go on and on and on. It works. It identifies which framework I'm working on. It identifies which language I'm working on. And I'll give you just one more example. Then I'll let the next speaker talk because I don't want to steal too much of your time. Just want to let you all know that this technology that we all know from Google autocompletion, now you can actually use it in your code, in your work in progress. Let's pretend that we have an array of persons, okay? Let's call it persons. It's an array of objects, sorry. And every object is made of person that has a name. You can see that I just wrote name, and since the GPT-2 neural network knows things about the outside world, about the real world, knows that names can be stuff like Jane, like Alice. So we have Jane, and her favorite color is maybe blue. Okay. And every element in an object needs an ID, right? Let's give Jane 1001. Then let's create the second object in the array. And the name will be this time Jack. And Jack also have a favorite color. You see, it already reads what I wrote up there. I'm sorry, it's too late. It's so late here. I'm usually fast asleep by now. And Jack's favorite color is green. And Jack's ID, well, the one before was 1001. Well, yeah, now it's 1002. And it can go on and on and on, and it can get a lot more complex, and it can fill up whole chunks of code just by reading a few lines of code. And well, I can go on and on about this, but I think you're all intelligent people here, and you see the powers this thing have. We have 27 lines of code here. I wrote maybe 3 or 4 characters in each one of them. So you're all welcome to try it and take AI into your work progress. In 5 years from now, it will be all over us. It's already penetrated most of the aspects of our lives, and there's no reason that we won't use it in our work as JavaScript developers. If anyone has any questions, then I'm willing to answer anything. And if you think of questions later, you can also email them to me. And thank you very much.
Okay, so I had read that GTP3 came out this summer. Are you going to switch to that, or will it be better with that, or I don't know?
Well, the main difference between GPT-2 and GPT-3 is that is the amount of pages that they were trained on. I think GPT-3 is 175 million, while GPT-2 is 2 million or 1.5 million or something like that. The difference is in the power, but I'm sorry, I'm searching for the word. My vocabulary is a little weak. The mechanism is the same mechanism. We get the results that we think that are optimum using GPT-2. GPT-3 is out, but it is still on tests, as much as I know. I don't know if we have any plans to implement it in our plugins at this point, but maybe we will eventually.
So is the plugin free, and is it open source?
Yeah, it is.
Cool.
Yeah, we do have we do have a premium Tab 9. It's called Tab 9 Pro. The main difference is that instead of sitting on your CPU, it uses external GPU servers, and it's cloud-based. But the results are the same results eventually. Anyone else?
Yeah, I'm curious. You said that it's trained on all this data. What about our data as it's training? Do you use that data or no?
It stays absolutely private. We're not taking anything from your project to the servers. Everything stays safe in your IDE. That's a guarantee.
Awesome. Thanks for that affirmation. It's very impressive. I look forward to trying it out.
All right, my pleasure.
Thanks so much, Yotam.
Hope you all will. Thank you very much. And I will leave my my email address here in the chat. If anyone has questions or just want to talk about AI, GPT-2, I'm here for you.
What if we just have questions about movie recommendations?
And movie recommendations too. I can also give you great guitar chords for everything.
All right, beautiful.
All right.
Thanks so much.
Thank you very much.
Okay. So, and our next presenter, Ryan from Prisma. So, Ryan, are you able to share? There you go. There you go. I like the mic.
On. Hey,
Pretty
thanks.
powerful.
Yeah, thanks. Oh, can you hear me?
Yeah, I said it's got me beat microphone-wise.
Gotcha. Oh, I see. Yeah. Yeah. I mean, not as portable though. This one is a little bit less. This is more of an.
Can't just wrap around your head and go.
No, that doesn't work. It doesn't work too well that way.
Cool. Well, thanks so much for joining us. And same question to you: should people interrupt you, or do you want them to hold off until the end?
We can hold to the end. I think probably best to do that. I'll kind of go through some code. So I'll do some live coding, and yeah, if you've got questions.
Tab 9.
What's that?
What's the point? Just use tab 9.
Tab 9. Yeah, I could now. I could just install it, and it'd be done. We'd be out of here. But I probably should try it ahead of time. So yeah, I can do the old-fashioned way here. I can share screen. Why don't I do that? And away we'll go. Desktop. All right, let me know if you can see this.
Yep, so far so good.
Cool. Okay. So yeah, hey everyone. Thank you for having me. I'm Ryan and I work at Prisma. Prisma is all about databases. And so we've got a few products that are all centered around giving you an easy and fun time working with databases, especially if you are working with TypeScript and Node. You may be familiar with Prisma from the old days. The old days were a couple years ago when the company was originally called GraphCool, and it was a product that was basically like a hosted API and database for you that was all based on GraphQL. So you would create an account and you would have like a GraphQL API out of the box, essentially. And then it evolved into a different company name called Prisma, and it evolved to a different product. And the initial rendition of the product was still to do with GraphQL, and it was, but it was more so that you had to deploy your own server. Now, version 2 of Prisma is out. It's different again, so it's a bit of a pivot. But what we found is that people really want to have control over their databases and how they're accessed, and they really want to have tools to help them, but have a lot of control over the whole thing. And so now we've got what we think is a pretty good level of abstraction, which is a bunch of tools that give you really easy database access. So one of them is our Prisma client. You can get a fully type-safe client to access your database. You will find it very difficult to do the wrong thing with this Prisma client because it's totally type-safe, meaning that you can't put numbers where strings are supposed to go and vice versa. It tells you what fields belong in your database and all that. So really, really easy and fast to develop with, and it's it makes for a great time. So the world's moving to TypeScript and largely to GraphQL, and we've got this Prisma product. We've also got something that we've been working on for a while called Nexus, which is a way to write type-safe and code-first GraphQL APIs. And so I figured I'd show a little bit on how to construct one of those, how to get yourself wired up with an API that uses Prisma, uses Nexus, is totally type-safe, and can eventually feed into the story of type safety for the whole stack. And I think this is a key point that a lot of people are focusing on now, is because type safety helps. You could say it sort of slows you down a little bit at the outset, because you've now got to worry about types, and you've got to annotate things with types, and you've got to worry about constructing interfaces and that sort of thing. But it's very helpful in the long run, because later on, when you refactor your code, and maybe you said you were going to make it look nicer and do certain things in a different way after you've put your product out, that time often doesn't come. Our code exists with technical debt often into the future. But if we can catch a lot of those potential problems with TypeScript out of the gates, then it makes for more maintainable code and a better product experience as time goes by. And so what Nexus does, and why it's really nice in this regard, is because it gives you type safety, but you don't have to do a whole lot of work to achieve it. It's going to give you basically everything you need for creating a type-safe GraphQL API. And it's going to auto-generate things for you. It's going to generate types, and you don't have to really worry about constructing interfaces and types and that sort of thing yourself. Same story goes for Prisma. It's a bunch of auto-generated stuff. So it's very cool, very, you can move very quickly with it, I would say. So this is what it looks like. This is if you're using Nexus. We've got some stuff being imported from @nexus/schema. We are making a schema. We've got this make schema object, which takes some types. And right now I've just got this single query type. So this is a root query type, and it's got some definition. It's saying that we want to have a field called hello, a string field called hello, that just resolves with a simple string called hello world. So I can go over to my GraphQL playground, and I can bump the size here, and I can say hello. If I hit go on that, there is that string. The idea here is that you don't need to write your schema definition language as one part, and then your resolvers as another part. So if you're familiar with GraphQL, you're probably familiar, if you've written GraphQL servers, you're probably familiar that kind of the default way, if you will, is you write your schema definition language. It's this thing that is like this kind of this domain-specific language. You would have something like a type of query, for example, and then it would have this hello field. That would be a string. It's required, something like this. This would be schema definition language. And then you would need to write a resolver to actually have that resolve with some data. All of that takes place right here in the same code block, essentially. It's just all done in one shot. So it's nice because you don't have to switch back and forth between your SDL, your schema definition language, and your resolvers. So that is kind of a bit on what Nexus is all about. And I figure what we can do is create a little API here, maybe for blog posts. That's kind of the most popular thing that we kind of teach on when we're showing Prisma. So we joke internally that we're making a living writing blog applications these days. And what we do, if we want to get Prisma in the mix, is we need to install it. So let's do npm install we need a dev dependency called @prisma/CLI. Prisma CLI, it is kind of what you think it would be. It's a CLI, it gives you commands to run and do Prisma things. We need that, and then, so that's a dev dependency. We'll just run that sort of locally here as a dev dependency. But we also need a regular dependency, which is going to be @prisma/client. We need the Prisma client, which is the basically it's the way that we're going to access our database to both read data and write data. So we've got those installed. What we can do is do npx prisma init. This is going to initialize Prisma in this project for us. And so when I did that, it creates this Prisma directory. And inside, I've got two things. I've got this .env file, and I've got schema.prisma with a lovely Prisma logo there. What is this file? .prisma files use the Prisma schema language, the PSL. So this is a domain-specific language, and it is the way that you create basically the map of your database. This is where you define your models. This is where you define how your tables take shape. You define multiple tables here, and you describe how they relate to one another. So this is the spot, this is the source of truth basically for the shape of your data, more or less. And you can see here, data source DB, provider is Postgres. We support, 4 databases right now, I believe. So there's Postgres, there's MySQL, there's SQLite. I think MS SQL is on the way. We don't delve into the NoSQL varieties like Mongo just yet. That's on the roadmap, but it's quite a different world. There's a lot of work to do to prepare ourselves to get towards that. Right now, it's all about relational databases. And so Postgres comes out of the box as it's configured here, but I'm going to switch up to do SQLite. SQLite basically looks like this. You just create something in your file system called whatever.db. So I've got dev.db. And so the URL I'm going to point to will be file dev.db. That's going to point over to this SQLite database. All right, so what do we do here to create a table? We can do model, and we'll create a post model. This is going to be for our blog application, let's say. The first thing I want is an ID field. So I describe my fields in here. I want an ID field, and I'm going to want a string. I'm going to want to put it as type string. So this is up to you. You can do it as like maybe an integer and have these auto increment if you want. I like to use some of the tools that come from Prisma to generate unique IDs. And the way that it looks is we want to set a default value, and we can use something like CUID. So that's a collision-resistant universal ID. The other option you've got is like a UUID for universal unique ID, but we got this collision-resistant one. We've got to mark this here as ID. We need a primary key field, and that's going to be our ID field here. So we've got ID. What else do we want? Title, I guess, right? Title is a string. We probably want a body for the post. And maybe that is enough for now. So I've saved this. I've got my definition for my post table. Now what we want to do is migrate our database. So that looks like this. We do npx prisma migrate. We want to save. And then we've got to pass this experimental flag. And that's going to come off soon. Right now it's on just to let you know that this is subject to change, the way that this works. But feel free to use it. Just be aware that things could change. So the name of the migration, we'll call it init. And so that's one step. We also have to run another step for migrate here, which is up. We want to do migrate up. And when we do that, we've effectively got our database migrated. We've got our table in there. This looks like junk right here, of course. That's not going to give us a whole lot of value. But what we can do is run npx prisma studio. And Prisma Studio is really cool. It's basically a kind of a 21st century PHP MyAdmin. We can click into here. We can add records if we want to. My first post body, something like that. So it's definitely a really good client for your database access if you want to just jump in to see your tables, see what fields you've got in there, etc. So that's Prisma Studio. So we've got some data in our database now. Everything is wired up. If we want to get it out of our API, why don't we do this? We will import Prisma client from @Prisma clients. And then we'll give ourselves an instance of that. Const Prisma equals a new Prisma client. And I was missing a step from before. The step that I was missing is that I need to do npx Prisma generate. What's going to happen here when we generate the Prisma client, like I just did, is in node modules, in this .prisma directory, we are going to get a type defined for us. We've got this post type defined now based on what we have described in our .prisma file, that schema.prisma file. So the idea is that we are going to do all of the work necessary to generate types for your database access. And then what that looks like for you is if we go into server TS, on Prisma now, we can take a look at what we've got. We can do Prisma dot, and we've got some methods that are specific to Prisma. But we've got this thing, this field here called post. And this represents that post model that we created with Prisma. And if we do another dot, look at what we've got. We can find many, we can find one. We can do all of these database access things that we would want to do. So that's really cool. We get, like, for free, we get a ton of value because we are shown what we can do. And if we, so if we could do find many, for example. But if we wanted to do something like .find, if we're coming from another database client world where there's just a .find method, it's not going to allow us to actually use that. So very cool. Why don't we do this? Let's make a Nexus type for ourselves. We'll call this post, and this is going to be an object type. So again, here we are, we're creating something with Nexus schema to give ourselves a GraphQL API. This is in replacement of writing this schema with the schema definition language and then writing a resolver. We're going to do it all in place here. We'll give it a name of post, and we'll give it some definition. And the definition will look like this. We'll have t.id, so that's going to be an ID field with the name of ID. We'll have t.string. We want a string field called title. And then we want t-string with body. That's going to be the definition for our posts. We'll want to make sure that we include it down here in our types array. So over here, we've got post. And now what we can do is on our main query, let's give ourselves a way to get the data out. So we can do t.field.list. We're going to say we want a list of things. We want to get posts. You know what? I think I've just made that backwards. t.list.field. There we go. We want to call this posts. And we will resolve with a type of post. And in the resolve method, we can do return Prisma post find many. Cool. So let's try that. Let's go over to our playgrounds. I'll just refresh to get the latest schema. And now, what do we get? Posts. Let's go for ID, title, and body. And if I hit go, there it is. We've got one post in the database. We've got its ID. We've got all the other details for it. So very cool. So that gives us basically like super quick GraphQL API, really great way to access our database. We can find another method. We can see how another of these methods work. Let's take a look. We'll grab this ID. If we wanted to find one, for example, just find one post, we could do find one. We could say where, and then we could say we want to find it where the ID is equal to this ID. And I will take off the list property there so that now we're just going to resolve with that single post, and that's finding it by its ID. What I want to demonstrate here is if we tried to include something like, let's say we thought that our IDs were integers for whatever reason when we're developing our application. We are not going to be allowed to run that query because our type system knows that ID needs to be a string. So we can pass a string. That's going to pass the type checker, but we won't be able to put a number, for example. So, you know, type safety, really, really key feature here. And what's really great too is if we tried to, this wouldn't take place in this resolver, but if we were doing something like Prisma post create, you know, we can create a post, we can pass it some data. If we tried to include, you know, let's say we did title, right? Title is my second post. Body can be my second post body. So that completes the loop here for data. It's satisfied. If we try to include something else like author, for example, it won't let us do that. It knows what is expected for our database. And so what's great about this is if we have some developers working on the database and then others working on the API, it becomes very easy for them to communicate without even really communicating with one another. They can just use the type system to make sure that they are working in a way that is expected. So that's very cool. What I want to show maybe as we wrap up here is the way that you would generate types, that you can work with auto-generated stuff here for your schema. And what that looks like is this. On Nexus Schema, we've got this option to do outputs. And there are two kinds of outputs that you might want to consider. There are types, so we want to do type generation. And there's also the schema, the GraphQL schema definition language. So why don't we start with that? So if we do this, we can say our schema. We just need to supply something here to tell it where to go, basically. And so let's see if I can remember how to do this. This might be dicey, but we can try that. While we're at it, maybe we'll just do the type gen as well. So schema is one thing, but type gen is another. So directory name generated and types dot ts, I guess, something like that. Let's save it. And what we should get now is automatically this generated directory. So let's talk about this, schema.graphql. This is that schema definition language that we were talking about. This is typically the way you would come to write a GraphQL API. You get the artifact of what you've written here in Nexus schema, a Nexus schema way of creating a GraphQL API. You get the artifact of the schema definition language generated for you if you want it. And what's useful here is you can then plug this into your editor, for example, using GraphQL extensions. And that's going to then inform you when you're developing your front end, if you're developing in React or whatever, wherever you happen to be developing. You can use this SDL file to inform your front end developers on what they can query for. So now you've got a bunch of communication pieces between your database access, your API access, but both in terms of like the back end and the front ends, and it ties the whole thing together really nicely. You've also got these types that are generated for you. So for example, we've got, let's do a search post. There we go. We've got this Nexus gen field types. Might be useful for you if you are wanting to apply these types elsewhere throughout your API. You know, you can make use of this as you see fit. So that kind of wraps up the little demo here. You know, maybe one thing we could just quickly do, I could show you maybe a mutation quickly just to wrap this all up. We can do const mutation. It's going to be mutation type. That's an import that comes from Nexus. And we can do, what can we do? Definition. And we will do t.fields. And let's call this create post. And let's define some arguments that are going to come in. We are going to want a title. That's going to be a string arg. So that's a function to execute. And we want a body too. That's a string arg as well. Then in our resolve function, we're going to get the parents. We're going to get the args and context, and then info if we wanted it. This is kind of standard if you're writing a GraphQL API. And what we want to do here is we want to insert this data into the database, essentially. So let's grab this. I think we can just kind of use this directly. Return an empty array there, just for now. Let's put this in here. We will paste that. I'm getting a lot of red here, which I am, oh, we need a type post. There we go, that satisfies things. We've got this args object. We can pull title and body right off of there. And now we can just destructure that in. We should be good to go with that, I think. We'll return this. I think that's good. I want to put my mutation type in place here into the types array. We can take a look right away. We get this mutation with create post and the arguments. Oops, I just messed that up. Create post with the arguments that it expects and the return type, which is post. And we can have a play with that, I think. Getting some type errors. String is not assignable to undefined is not assignable. And I think that's because I have to say nullable is false, perhaps. Nullable, false. Perhaps not. Let's take a look. Not exactly sure why that's popping up, but anyway, let's try for a mutation. And it'll be create. I'm just gonna refresh to get my schema here. Create post. And what goes in here? Title, my third post. I'm getting a lot of this helper screen. That's not very helpful. And body, post, body, something like that. And we'll return with an ID, title, and body. Does this go? It looks like it goes. We've got an ID. If we head over to Prisma Studio and refresh that, there it is, my third post, which is actually the second post in the database, but you get the idea, I'm sure. Yeah, so that rounds it out, I think. Check out Nexus Schema. Check out Prisma.io. We've actually got an event. It's our very, very first Prisma meetup. We do a number of meetups around GraphQL, around TypeScript, etc. This is the very first Prisma meetup on October 28th. So if you are interested in joining up for that, head over to Prisma.io. And yeah, I think that's about all I got. So happy to take questions now if anyone's got them.
We're going to plug, so.
Thank you.
Good stuff. I would like to check out the meetup, and I'll share that link if that's okay.
Yeah, great. Thank you.
With the group. So questions. Who has questions, comments? Are you guys hiring by any chance?
Prisma, you can check out, what is it? Let me find the link. I think it's just /jobs. Prisma.io/jobs. That's the one. Head over there. There's some open positions. What do I see? Developer advocate, engineering manager, and TypeScript engineer are the jobs up right now.
Beautiful.
Yeah, check it out.
Cool. Anyone have any questions? You can type them in chat or you can shout them out. Ryan, do you mind dropping some contact info in chat just in case anyone does want to reach out for you after the fact?
Yeah, so twitter.com/Ryan Chankey. You can get me there. That's the best place. I mean, if you like email, I'd take an email from you. You can hit me there, Chankey@prisma.io. Yeah, come say hi.
Cool. Well, thanks so much. Thanks everyone for coming out tonight. Coming out, I mean, online, whatever it is. Thanks for taking the time. Thanks for continuing to help build community. It's just a matter of time before we can get back to in-person meetups. I'm looking forward to that. And yeah, so if there's anything you want to talk about, just get in touch. If there's a presentation you want to give, reach out to me and we can make that happen. All right. Thanks, everybody.
Bye.
Have a great rest of your night.